Hello, my name is Christian Frank, and this is the video for ECE376 Embedded Systems Homework Set number 6. For this homework set, we're supposed to write a program in C that uses an analog input and an output on NeoPixel. For this assignment, I wrote a program called Self-Regulating Light, which takes its analog input in a light sensor and then outputs on the NeoPixel. For my program more specifically, I incorporated a voltage divider which utilizes a 1k ohm resistor and my light sensor. And the analog input is put into the PIC processor, which then processes the input analog data. The LCD display will then output the input voltage that is coming in through my input analog data. It will also then calculate the resulting resistance of the light sensor itself, and in addition it will calculate the lux level of the light that the light sensor is reading. Finally, it will also display the current light level of the NeoPixel LED, 0 being fully off and 255 being fully on. So it will range between the number 0 to 255. And it will display all four on there. In addition, the output on the NeoPixel, it will increase or decrease the light. The goal being that this light is going to come and sit up above the light sensor like so. And the LED will increase or decrease in brightness as needed to try and get the input light into the light sensor to read 100 lux. So if it's reading more than 100 lux, then it will try and decrease the light out of the LED to lower the light level where it's brings it either to 100 lux or the LED is completely off. And if the light level is reading as lower than 100 lux, then it will try and increase the LED to the point where either the light sensor then reads 100 lux or the LED is fully on. Therefore, it is a self-regulating light system. The LED light will increase or decrease as needed to keep a constant light level coming into the light sensor of 100 lux. So I will begin my program now. Just got to plug it in here. Now, as soon as I plug it in, the first thing that you see is the nice title, Self-Regulating Light, will appear on the screen for 5 seconds to let the user know what it is, and then it will begin immediately. After 5 seconds, it immediately displays all the information. So right here, we have our lux. It is currently reading about, let's see, it's varying some, but for the most part about 250 maybe, averaging, some higher, some lower, as our input lux level. And over here we have the voltage that is being input into the analog source and the equivalent resistance in the LED sensor itself. So using the analog input voltage, we're calculating the voltage right here, displaying it. We're also calculating the resistance and the lux. And then this down here on the bottom, LED, is displaying what the current light level is of the LED. Since the lux level is above 100, the LED is trying to be as fully off as it possibly can, which is at 0 currently, so it's completely off, as we can see. If I come over here and I shut off the light, you immediately see the LED turns on now. And it's a little hard to read. Here you can see it keeps counting upward and then stops at 255, the maximum brightness that it can possibly be. Now the LED is shining as bright as it can possibly shine right now. But where the neat trick comes is right here. As soon as I shine up, the LED, though you can't really tell, but the LED is now decreasing and will regulate at the level that it needs to be 100. Now, if you can't really see, the interesting aspect is when you bring it really close. When you bring it really close, what happens is there's the time delay in the program. So from the time when the light sensor reads the LED as too bright, it sends the input signal, processor realizes it and tries to decrease the LED light. But once it decreases, then it realizes it's too dim and tries to send the next signal saying it needs to increase, and then the PIC gets that signal and starts increasing it. But because of the time delay, by the time it realizes it's too dim, it's still in the process of trying to dim the light. So what ends up happening is it dims the light way past the point that it's supposed to, and then brightens it way past the point it's supposed to. So when it's really close, you will see this constant flicker effect happen. So once we bring it down, you will see the light will start to flicker constantly on and off from the light sensor. To show you, that's the best example. Here you can see the light is trying to self-regulate. The only problem is that the amount of time it takes is too long, and this is the fastest that the program can really be. It can't really speed up beyond this. However, so it doesn't seem to work too well there, but if you raise the light to being about 6 inches above the light sensor, then you can't see a flicker, and the LED seems to maintain pretty constant. Now, to show you on the display, as I said, on the display it tries to regulate it to 100. So now I will show you on the display that it is indeed trying to regulate the lux to 100. So as soon as I take the LED and I put it above the light, we see it instantly lowering the lux, trying to get the lux to 100. And boom. Now we can see it's constantly staying there. It's going a little above, a little below. And we can see that the LED level is changing as well. So it's slowly increasing and decreasing the brightness of the LED each time to try and keep the light at a constant 100 lux. Now when I bring the light really close like before, you'll see what happens with the flickering. So here it's trying to keep it at 100, but each time it's reading it as like 160 lux, all the way down to like 30 lux it appears. So it's reading it so drastically, so the LED is quickly trying to adjust. And we can see also the LED is not adjusting very much in brightness. So we can see when we bring it this close to the light sensor, you don't really have to turn it on for it very much for it to already be above 100 lux. So there's the problem, is it's trying to regulate, but with the amount of time that it takes, and with such drastic change in turning on and off the LED that happens, it's too close for it to be able to accurately maintain the level. But as soon as we raise it up to that 6 inches mark, now it can accurately regulate the light. So there you have it. That is the self-regulating light. The light that shines on the light sensor remains as a constant 100 in order to maintain a constant light level. So that is my program. And once again I turn on this and it will keep decreasing the LED until it is fully off. There we go. Thank you for watching.